right? So the components of this of the blood, right? Now, if we take a small section, well, a small amount of blood and put it into a centrifuge, so we know that centrifuge would actually rotate test tubes, right? Separating things based on their density, right? So we're gonna have here, if we centrifuge blood, we're gonna end up with different percentages. So generally, right, we're gonna have here, right, the different sections of blood. So we're gonna have just blood plasma, right, in one area. Then we're gonna have a whitish coat, which would consist of a lot of white blood cells, leukocytes, right, and platelets. And then we're gonna have a good amount of the blood being erythrocytes, right? So these shows the sections, right, of are the components of blood specifically, right? So we know that the plasma is a watery substance. It's usually 90% water, right? And other types of things like nutrients, right? Minerals, hormones, anything like that that exists within plasma, right? But the difference between plasma and serum is that plasma has coagulation factors in it, right? So plasma has coagulation factors in it, but serum doesn't, right? So serum is just plasma that has no coagulation factor, right? So I want you guys to really note that. Now, the blood cells, though, that we have here, right? So we know our general erythrocytes, right? So our general erythrocytes would be our blood cells, right? And their main function is to carry oxygen, right, to our cells and carry carbon dioxide back to the lungs, right? So we have the erythrocyte that like that. We know that the red color is due to hemoglobin being present. Hemoglobin, which is a quaternary structure, right, of protein that has that has other groups on it, right? So it has different types of groups on it, well, are different groups on it, right, that are all generally made out of iron. So these are heme groups, and this gives it its red color, right, the red color of hemoglobin, right? And these heme groups, right, really trap oxygen. And we're going to look at the affinity for oxygen and stuff like that within the Bohr effect, right? So those are erythrocytes. Then you're gonna have your leukocytes. Notice that we're gonna have leukocytes like basophils, right, and neutrophils and eosinophils, right, lymphocytes, right. So we generally have those monocytes. Now those are what really turn into macrophages, dendritic cells, right, and they can differentiate into um, T cells and stuff like that, as we're gonna see, right? But generally, leukocytes speak to white blood cells, right? Leukocytes can be divided up into many different sections, but generally, we have phagocytes and lymphocytes, right? So we should know that a phagocyte, right, would generally be a cell, right? The phagocytes usually have lobed nuclei right, as well, right? And the phagocytes contain lysosomes, right? Or what we call phagosomes, right? And what they'll do is release enzymes that break down pathogens. So if the phagocyte comes in contact with a foreign body, right? So if it comes in contact with a foreign body, we know what will happen generally. So the phagocyte would actually change its cell structure, right, to engulf, right, through phagocytosis. And then it will create different, it will move its vesicles, right, releasing enzymes that will break down the wall, right, of the foreign body. So we should generally remember what phagocytosis is, right? And this is what phagocytosis is, right? The engulfing, right? It starts with engulfing by the phagocyte, right? Engulfing that foreign body by the phagocytes, right? Then the phagocytes release vesicles, right? Creating a phagosome here, and then releasing these digestive enzymes to destroy whatever is there. So phagocytes generally do that through phagocytosis. But lymphocytes now generally have a more calm shape, right, with a more spherical nucleus, more so than a lobed nucleus, and they create what exactly? Antibodies, right? So they create immunoglobulins, right? We can look at the structure of immunoglobulins later, though. So they create immunoglobulins, right? And these immunoglobulins, right, really help with immunity, right? So all leukocytes help with new immunity, right? So those are generally the blood cells that we look at, though, when we're talking about the structure of cells. When we go into immunity now, then we can talk about neutrophils, eosinophils, macrophages, monocytes, dendritic cells, cytotoxic T cells, right? All of these other leukocytes, right? But last but not least are platelets, right? So platelets are usually really tiny compared to the other structures within the blood. So platelets are used for blood clotting, as we should remember, right? So yeah, so platelets are just, that's really their main function. So if we want to really have you know, a time, right, to actually go through blood clotting, then we could go through that. But platelets really go through that, right? So they really allow for some coagulation of blood, right, and for blood clotting to open over any breaches within blood vessels, right? So platelets really have that main function. So erythrocytes usually transport of oxygen and carbon dioxide, right? Leukocytes, immune function, right? And platelets, right? Any type of, well, it will be used to heal mechanical injuries, right? Such as breaches to the blood vessels using blood clotting, right? So those are the components that we know there.